Our school was invited to the annual Pumpkin Chunkin contest. Schools across the state design and build catapults to see whose machine can launch a pumpkin the furthest. The contest was in 1 week, and my team's catapult was a disaster. When we shot our pumpkin, it went wildly off course. Last night, I was very worried about what we were doing wrong, and I fell asleep trying to figure out how to fix my team's problem. As I drifted off to sleep, I dreamed I was back in the Middle Ages during a raging battle. Soldiers were trying to storm a castle where their beloved queen was being held hostage. They had catapults, but all of their shots were flying over the castle and not making a direct hit. They needed my help. At first, I wondered what I could do, and then I remembered. I knew quadratic functions. A catapult is a machine that launches objects far distances. It has been used since ancient times as a weapon. The premise behind a catapult is simple. Harness stored or potential energy and unleash it to propel heavy objects. In most cases, it used heavy castle-smashing stones. Things that are thrown in the air, like golf balls, frisbees, and footballs, all follow a path called a parabola. A parabola is a symmetric curve that goes up and down. It can be written as a quadratic function and written as a graph. The problem the medieval soldiers were having was that they were just considering the distance. They weren't properly accounting for height and velocity. They needed to use all the variables. We worked it out with some simple quadratic equations. And when they added height by increasing the angle of trajectory, the castle was sacked, and we saved the queen. I woke up and knew what was wrong. We needed to use a quadratic equation to model the parabola. This would tell us where to place our catapult in relation to the target. It worked! Our accuracy went from 2% to 99%. We can't wait for the competition. In this unit, you will learn how to graph quadratic functions and use quadratics to model real-world scenarios like ballistic motion.